And then my last note is Mary, the links to the CEU information and the Google Meet room is listed on the back channel document.
Okay.
Google Meet room is listed on the back channel document.
Okay. Okay, it's 6 o'clock. Shall we start?
Sure.
Okay, good evening, everyone. Good evening, everyone. I'm Mary MosquitoMapper from Sourcewell Technology, and I am just facilitating this session this evening. We have with us David Lockett and Denise Wright. Both of them are NASA Solar Ambassadors and STEM teachers. And with that, I'm going to go ahead and turn it over to them.
Wait, go ahead and let you introduce yourself.
Okay, sure. My name is Denise Wright. I am from Myrtle Beach, South Carolina. I'm a STEM teacher. I volunteer for NASA as a solar system ambassador. I've been teaching for 22 years. 7 of those years were online. 3 years ago, I returned back to the classroom, and I currently teach like STEM at a middle school down the street. So I'm using a lot of my online teaching skills again, now that we are in this remote environment. And we're going to be talking to you tonight about citizen science, and we're excited to be here. Go ahead, David.
Hey, David Lockett. I'm a STEM computer science teacher located in Central Florida, NASA Solar System Ambassador as well. So, you know, a lot of space projects for our students, a lot of space science. So got some exciting programs we're going to talk to you about today. Citizen science, open data innovation through NASA programs, projects that you can do with your students remotely, and hopefully when you get back to that classroom.
Okay, we just want to say happy National Space Day. Today is May 1st, and it is National Space Day, and it's a day we just celebrate space flight. And if we were in school, we'd probably be launching rockets, and there's a lot of exciting things coming up this month. For example, May the 27th, we're going to be having our first manned SpaceX launch, a commercial space launch. We'll be sending 2 astronauts to the ISS out of Cape Canaveral, Florida. So we haven't sent astronauts up in quite a long time. So that's going to be a very exciting launch on the 27th of this month.
Yeah, and coming up this summer, they've got the Mars rover. It's launching from Kennedy Space Center. So exciting times in space. Hope you're tuning in as all these exciting things are happening.
Yep, we had a 7th grader actually name the rover Perseverance. We had a big contest a few months back.
Yeah, it was a fun time.
Yeah, so we also want to highlight that since we are ambassadors, there is a program called NASA at Home. If you need to use anything for your remote learning curriculum, there's things like ebooks, there's virtual field trips, there's videos, you could podcasts. So we'll be sharing this presentation at the end of our time here. So if you need any of these links, you'll have access to those as well.
And I know my students are taking advantage of the virtual tours, the virtual field trips. You know, a lot of them are using their devices at home, and you know, what better way to do that than, hey, you've got your NASA virtual tours. NASA at Home provides some great options for remote learning and activities that students can do at home.
Another one is the Astronomical Society of the Pacific. I'm a member of that organization as well. They'll be doing some programs for elementary school students, like story time, which deals with astronomy topics. They're going to be featuring things coming up on light pollution. We are really concerned about light pollution because it's going to impact our night sky and what we could actually see at night. We don't have a lot of pure dark sky left out there. So they're going to be talking a little bit and featuring that as well.
And I do know with the Astronomical Society of the Pacific, there's different challenges that students can work on as well. Can they use this with their cell phones as well, or?
There is a citizen science project that I'll mention today. It's called Globe at Night. And you can actually track a star and how many nights you see it in your community, and be adding to that data in terms of sky pollution. So there is something out there as well for that.
Here's another project. You can integrate this across the curriculum with TI codes.
Yeah, this is for Texas Instruments as well. This is due the 21st of this month. Basically, your students are going to be able to connect remotely together, and there's a specific challenge that they have to complete dealing with the ISS. And we're celebrating the 20th year of the ISS. So definitely check this out. This is with Texas Instruments as well. And it's a coding challenge, and they're using Texas Instruments in designing something for the space station. So this is another great activity if you're looking for to push your high school students at work at a higher level. So, and we'll provide that at the end as well.
Now, I found with the TI codes too that students don't need calculators because there are online simulators that they can work on as well.
Yes, thank you. Yep, good point.
So, hey, here's our goal. We want to, make an open collaboration ecosystem for citizen scientists to derive solutions to global challenges for all students. So, how can we get there?
Okay. And many of you, if you're here this evening or you're watching, you may not know what we mean by citizen science, but what citizen science basically is scientists need help with their research. So anyone as young as kindergarten all the way up through adults can be a citizen scientist. And scientists need help with collecting that data. So common everyday people like our students, like ourselves, can go out and help contribute to these projects and help these scientists on a global scale. And there are lots of projects we're going to talk about. A lot of NASA themed projects this evening, but there's a whole bunch of other ones as well.
So if you take a look here, anyone can participate in these projects. We've got multitude of activities that students in all grade levels can work on, from the comfort of their own home.
So we're going to form a public participation in citizen science. Again, it involves volunteers and it's authentic research, and you're able to connect with scientists. So it's really a great idea if you're looking for, in your remote learning, a way to get students involved in real world research. These projects are not really heavy and in depth. You can do a citizen science project 10 to 15 minutes. You could introduce it in this remote learning environment and then have students go out and do it right outside their front door. So they're really easy projects to participate in, and we'll be highlighting several of those. And again, we have that lovely Venn diagram up there where we're talking about public participation in science. We're talking about collaborating with these scientists and getting people to collaborate with one another. And there's a whole bunch of online communities as well to share all the data that they're collecting and find out some of these great discoveries. And we also call it crowdsourcing.
Hey, one of the biggest aspects of citizen science that I've taken away so far with my students is the authentic learning aspect. How they're integrating this authentic learning and this authentic science, and they're connecting with scientists, real engineers, real scientific the community.
So some of our objectives for this is basically we're going to derive misconceptions about science and what is science exactly. We're going to help the public understand and participate in the citizen science and open science. We're going to compare and contrast science with other scientific research and endeavors. And also we're going to demonstrate one way to contribute to citizen science through biodiversity platforms. Again, we're just mentioning that we're featuring a lot of NASA things this evening, but there's also citizen science projects in language arts and math and science and environmental issues. So we'll show you where some places where you can find those this evening as well.
Hey, that cross collaboration is, obviously important when you're learning across the subject. You want all students to, activate, all types of learning, but you want them to be able to contribute as well.
So if we were to draw a scientist, okay, what kind of tools or accessories would the scientist have? Okay, so we're trying to make students sort of think outside the box, and would there be a girl drawn there for a scientist? Okay, that's sort of important. That's an important question. What kind of tools do they use? And those are some great questions to sort of pique curiosity and see what students have to say, and some interesting questions to ask to see what kind of responses you would get in your remote learning sessions and in your classroom.
Even working with my middle school students, providing this answer, you have so many different responses. And what they start with and what they end with is is so different, because they're being exposed to something new, they're being exposed to something different. You want them to be exposed to that those 21st century learning experiences that are unique and different.
So the common feature of these projects are that anyone can participate. Basically, participants are professional scientists who actually get the project started. And basically, the data they use everyday people to help analyze this research and advance research, and also help with the decision making. There are citizen scientists out there that have made major discoveries, definitely in astronomy. There was some star forming regions that we didn't know about before, but because of citizen scientists and people collecting all this data, we were able to find that information out. So that's exciting information as well. The public as scientists, we have access, and we can also use the data. So we can have our students take that real life data and graph it. And it's real important that we all know that students work with real life data, and it makes them understand, how science works, how data is collected. And as we all know, we want to make our classrooms real world. So having that real-time data is very important.
I know when we were collecting data with my students, we worked on the OSIRIS-REx project, and they were mapping areas of meteorites. So there's interesting projects out there. All students can participate, and there's they're getting that new knowledge, and they're sharing it, and they're understanding how data is used.
Okay, so one of our major platforms that has all these citizen science projects on there that we're going to feature this evening, and we'll show you some more specifically in a little bit, but one is actually called Science Starter, sciencestarter.org. The projects are actually classified according to age, subject area, location in the world too as well. Some are global, some are in your local community. Some are national. So if you are teaching just about anything from English to math to science to social studies, you can search for a project on this Science Starter. And as a matter of fact, today's May 1st, but last month we were celebrating Citizen Science Month. So that's has been an exciting month as well. Lots of people sharing out their findings on social media, and a lot of different opportunities out there to bring real world research into your classroom. And this is a great spot to check out. So we definitely recommend this one because it has over 3,000 projects on there.
I like SciStarter because if you look on the screenshot we have, it's find location, select a topic. It can show you citizen science projects that might be in your particular area and how you can add your students' research and data to it as well. We've used SciStarter in our middle school classroom for the better part of a few years. And our students love it because they can not only explore, but you've got a robust amount of information that's available for student learning.
David, that's really great. I know that I did ask the audience if any of them had tried any of these projects, and just did get a response back that they hadn't used any of the ones you're mentioning, but we do have some projects that people have done around the Mississippi River here in Minnesota. So thanks for showing that one where they can search by area.
Yes, you're welcome. It sounds like you're definitely engaging in citizen science right now.
So you can set up a dashboard on citizenscience.org, or not citizen science, but sciencestarter.org. The dashboard allows you to actually keep track of your actual projects that you're participating in, your contributions. It has it all in there. So if you decide to have your students participate in numerous projects, they can go to Science Starter and actually create their own account to do that. And you can see this person here is actually doing a citizen science project with bats right now. So
I like how you can track contributions. So, if you have a specific number that you're looking for, say, a research class or a science Olympiad team, students can say, hey, these are my contributions. So great way to follow along as you're going.
And David's just highlighting there what we just talked about, the project finder, the location, all the activities that are listed there. And you can be very specific, so you can find that exact project. And really great also if you have any kind of technology fair, science nights, to really be able to pull in that information that's already out there and then add to that information. That really makes students understand the importance of data, and the more data, the more valid your experiment.
Well, there's kind of an information page about the number of projects and reports that are out there for some of these different projects. Some of the projects have, a good amount of data, and some are new, and some are, exploring.
Oh, these are our ISTE standards. If you're a member of ISTE, it's International Society of Technology Education, and we want our students to be constructors of new knowledge, global collaborators. We want them to think computationally. So these are some great standards, and we're meeting a lot of those standards by doing these citizen science projects. Being global is very important, and there are citizen science projects out there that make a lot of global outreach as well.
I always say, hey, you're connecting to, you're connecting these projects to the larger world of science, but you're also connecting across the curriculum. You want your students to be collaborators. You want them to think computationally. You want them to understand problems. So it's a good way to, give students those learning experience that are going to, help them solve problems, develop solutions, and become, better thinkers and better learners.
Hopefully these projects are going to definitely inspire you. What kind of project do you find inspiring? What do you want to do? What can you do? What would make you interested in participating in citizen science? We definitely want to pique the student interest. We want to get them excited. We want to make them passionate. Another way to do that is possibly a choice board where you highlight 4 or 5 different projects, and then the students get to select which projects they're interested in. It could be anywhere from nature to astronomy to social studies. So if you're interested in getting just kids involved in real research, that's also a suggestion as well.
Here's a favorite that I've actually used in my classroom with my students. Being in Central Florida, the weather's a little bit warmer, a little bit more humidity at times. So we use an app called the MosquitoMapper. And with this particular app, students can use cell phones, they can use tablets. When they use this particular app, they're actually looking at standing water that could be located around a school. It could be located at home, and they're looking at the larvae that's in that water for mosquitoes. And it's a free app, and it's got several different projects that students can work on, review, and send observations.
Right, and we're concerned about mosquito populations because mosquitoes actually spread disease. Okay, so that is an area of concern. So that's very important that we are aware of that. NASA satellites cannot track mosquito populations, so we need people on the ground to do that. So that's why we need citizen scientists. As you can see out there in that picture, David's students are outside and they're out and about collecting that information. So that's a great way to get their students outside with their devices. Also, a good indication of mosquitoes is, after a rain. We all know that when we have a lot, or an area experiences lots of rain or flooding, mosquito populations have a tendency to increase. So a lot of our mosquito population is dictated on weather. And again, globally, we're collecting this data. So our students have access to that. They can present presentations on that. And again, it is important that we do know about these mosquito populations, because, if a certain area of the world, is getting sick, is that the mosquito that's actually carrying that illness. So and again, this is through the NASA Globe Observer app. At the end, I could show you the app on my phone if you'd like to see that. But these actually are all contained in one side, inside of one app called NASA Globe Observer. So if you have your iPhone or your Android and you want to download NASA Globe Observer, you could feel free to do that, and have your students do that as well. It does work on Android and iPad as well.
I would note too that Minnesotans are quite a plague in Minnesota as well. So a lot of people have been commenting on that in the chat. So thanks for
Oh,
that.
yes.
Yeah.
And there's just some goals of the MosquitoMapper app. As you work on them and as you download the app, you'll see that, of course, scientific data collection analysis is number one. You want to engage your students, you want to keep them, responsive, and you want to make those connections. So, just one of the few apps that will show you that's listed.
The next one that David is showing you is also contained in the same app, and it's called the Globe Observer app. A lot of science curriculums cause us to look at clouds, especially when we're studying weather. That's a big thing that we do teach in all grade levels. And so NASA has the ability to receive data, obviously, from space, but they don't have the same ability to receive data on the ground. So that's why we have our citizen scientists helping with those observations. This Cloud Observer app is really easy to manipulate and go through. I could show you a sample in a little bit. You're just basically classifying the clouds based upon their size, their color, what the sky looks like. After you download the app, it only takes about 5 or 10 minutes to make an observation. If you're in this remote learning environment, you could probably be in your Google Meet, and you could be outside with your cell phone and show students how you're collecting this data. Also, clouds are really important because they actually also deal with heating our Earth, and that cloud cover has a lot of effects on weather too as well. So, so there's David's students out there collecting more data.
And they really enjoyed using this app. I tell them at the beginning of each year, you can use your device, for more than Snapchat, for more than TikTok. You're using your device for scientific analysis and data. And they were amazed. They were truly amazed at this. And, I had some that, every day, they were taking these globe cloud measurements. We had overcast days, or it was storming. They were kind of upset and bummed. So, great way to get them, out and about.
Okay, and again, as you can see, the person there holding their cell phone and the student holding their cell phone, these are all found in one app called the NASA Globe Observer app. This is the Globe Land Cover app. We're going to look at, the amount of land cover in a particular area. That's going to allow us to predict wildfires. It's going to allow us to predict erosion, possibly landslides in the future. So we are actually collecting data on the land cover in our particular area. And that gives us a lot of information, and again, can be applied in social studies, probably class, as well as science. So, and these apps, so you understand, are very intuitive. If you open it, it's a step-by-step process. It walks the students through, and they're really not that difficult to use, because David and I both teach middle school, and our kids have used it. Your kids can use them as well. Elementary level, you may have to give them a little bit more guidance, but I even think on an elementary level, K-12 actually can definitely use this app.
Do we have time for this video or?
Where are we in pacing? Let's see, we're about 25 after. So I don't know how long this one is, David.
You are fine. It's only about 25 after, so you have time.
Okay. Do you have some volume on that? Can you turn it up? Because I can't hear it. David, are you hearing anything?
Yes.
Okay, because I don't hear it here. Are participants in the room hearing it?
No, I'm not hearing it.
Yeah, we're not hearing
They're
it.
saying no.
Okay.
Yeah.
I'll leave the link in there. That way they can still watch it.
Yeah.
Yeah, that's good. And then maybe I'll share, like I said, I can share my cell phone at the end so that you all can see a little bit more in detail of the app as well too, as we're talking about it. So there's a
Yeah,
little video about 3 minutes
you're
long.
not-
Go ahead.
Sorry, Denise. It may be because you're somehow not sharing the computer audio along because you got your mic on. So just leave the link in there. One request I have had from the audience is if you
Yes.
would be willing to share this slide deck as well. So,
Oh, definitely.
Yes,
yeah,
absolutely. That's part of it. Yeah.
Yes.
Great. Okay.
Yeah. This one here that David also just pulled up is this in the Global Observer app as well, NASA Globe app as well. It's called Globe Trees. Trees contribute to oxygen, biomass in our environment. This is really great because I've actually had students go outside and what you do basically is take your cell phone. Your cell phone acts like a measuring tool. And you can actually use the camera feature to measure. It's pretty amazing from the base of the tree all the way to the top. So it'll give you your latitude and longitude where automatically where you're located at. So if it's there in Florida, so that's his latitude and longitude. So it's a great social studies component there. And when he measured that tree, that palm tree there, was about 4.6 meters in height. You also do mark the conditions of each of the areas, like where you're collecting the data based upon the snow, the standing water, the dry ground. So you're marking all those observations. And then that's the data that David got at the end. And so what you do is you have a student screenshot it basically on their phone or on their iPad. And then you could upload all this data to a Padlet. So when you go back inside, you've got all these different trees on your school ground, and you actually have their height. And you can, definitely apply this to graphing as well. We can graph the data of the tree height in our environment on our school property. There is a button at the end of this app where you're actually sending your actual data to NASA. So that's something really great as well. And again, they need this data because they need to know about, oxygen levels in our atmosphere, carbon dioxide, biomass. Trees obviously help with temperature and things like that. So that's that app. I don't know, Dave, if you had anything more to add.
Yeah, they love this app because, they were making those connections. And obviously when, other teachers saw this, like, wow, we can connect math, we can connect social studies, and that's when, hey, we're going to start using these devices for something different. So, we tried it on a palm tree. Yes, they work on palm trees. So, seeing how these different citizen science maps can work over time were, particularly important to students. So we had some that mapped trees over the course of the year, and they were amazed. They're like, wow. They were, hey, this is my data. This is what I've taken. This is how we were engaged in it. So definitely trees.
If we were back in school, we'd be able to, hey, there's a tree in August. Here's the tree in June. How much height difference did we have over that period of time? So that would have been interesting as well. Yeah.
Oh, here's the ISAT.
Yeah, and that's basically the satellite that is actually measuring the biomass in the trees. It's actually it's a laser, I believe it's LiDAR. It's a special type of laser photometry that is actually measuring that bounce back from that satellite. So there's a STEM aspect to talk about too, technology, how, students can actually research how that, works, the altimeter in there, and, how is it measuring from space and getting that information. That's something really neat as well, because we do have lots of satellites out there orbiting Earth, and how what are they there for? They're there to collect that important data that we're learning about all the information on science all the time. So yeah.
Yeah, definitely cultivating that space science learning.
The other one also, again, these are
Should
all
go
in the
trees.
same app as trees, and we just finished talking about that, and that's a little bit video as well. Okay.
Few guidelines for choosing the trees to measure.
Right. And the tree should be 5 feet tall, though we found out here in the South, with between David and I'm in South Carolina, he's in Florida, they do measure palm trees that are below 5 feet. So but we got it to work. But yeah. Okay. Now, your students don't have cell phones. Your students may not have iPads, although you can do these on cell phones and iPads as well. This project is actually called Zooniverse. These are web-based projects. So if you are a teacher in a school that has absolutely no devices and you're the only one with the device and a whiteboard, you can all do a citizen science project together. Okay. Or if you're a school that only has Chromebooks and you don't have iPads, you don't have iPhones, you can do these citizen science projects on your Chromebooks as well. Obviously, David and I are highlighting NASA citizen science project or space-related citizen science project on this website called Zooniverse. There are other ones besides astronomy. But some of the ones that I have participated in with my students are the radio meteor zoo. In an online environment, when I taught previously online 7 years ago, or for the last 7 years, when I made my students do citizen science online, because I thought it was very important. Even though I wasn't with them face to face, I still think it's really important that we expose them to this real life research. So with those observations, they would have to take a screenshot and then upload it to an online forum. So, and then they would have to write a few lines about what data they collected. So in a Google Classroom kind of environment, if you're trying to get these students to participate in these projects remotely from your homes, that's a great way to do it, is just for them to have to take a screenshot or photograph, and that works really well. But the Radio Meteor Zoo was basically measuring, they gave you the data already. There was some graphical data that you had to read to determine if it was a meteor or not. There's tutorials that come along with all of these. They tell you a step-by-step process on how to do these projects. They're not difficult. I mean, you're like, oh my goodness, an exoplanet. How am I going to figure out, teach my kids that what exoplanets are other planets besides our own out there. All students are looking at is a change in the graphing data, a change in the peak of the light curve, because planets, exoplanets, or additional planets out there usually orbit just like, they orbit around a star, just like we orbit around the sun. And when they go behind that star, the light curve changes. So all students are doing is just looking for a change in that light curve. And you're applying real world data. If you're teaching space science or you're teaching math, that's something great to look at as well. Some other ones, there's something called Galaxy Zoo, where you're actually looking at galaxies and looking at the shape of the arms. There's 3 types of galaxies: spiral, elliptical, and irregular. Sorry, taught astronomy for quite a long time. So you're able to actually look at the actual pictures and classify them. So being able to put things in according to classification. So again, these projects are for common everyday people. They give you a tutorial. The tutorial is about 5 minutes or so. And you familiarize yourself with it, and then you present it to your kids, and they participate right on their computer, or you could just do it on your whiteboard, or you could do it remotely with your students in this type of environment.
Zooniverse has been very consistent. They've been adding, I think, 2 projects a week since the shutdown happened a few weeks ago.
Yep. And this is the one on exoplanets that I thought was really interesting. It's additional planets beyond beyond ours out there, and being able to identify one. That'd be really great if you're a student who identified a planet, an exoplanet. Some of the exciting discoveries for NASA citizen science. So like, okay, So we do these projects, you know, what happens out of it? Okay, there's actually been remarkable discoveries from students, from middle school students. They found caves on Mars, they found exoplanets, they found these star forming regions. So you would think that, you know, hey, you're just doing this project, but you would be surprised. Students actually make major scientific discoveries by participating in these projects.
Hey, that's the building blocks of research.
Yep, and that's a video on that as well.
I was just
Yep.
going to stop and ask you a
Yes,
question
sure.
there, David and Denise. I'm just wondering if the idea that the students are actually acting as science, do you kind of communicate that with them, and does that engage them more than you think they might otherwise in a project? I'm just kind of curious about that.
From my standpoint, I'd say it's definitely cultivated, new attitudes in the students where they can say, hey, I'm actually a researcher. I'm taking part in this research. It's necessary for STEM. It's necessary for astronomy. They're using these observations to not only communicate, but they're using it to improve their understanding. So yes, I say it's empowered students.
Yeah, and they're very surprised. They're like, "You mean this stuff is real? Like you're just not making that? No, we're not just making this up. This is real science, and you're participating in it, and you're making an impact. You're helping this scientist." And I think when they realize that they're helping someone with their research, it's definitely making them feel like empowered and going out and wanting to collect more data and help contribute to that greater good. So it's definitely great because it's really showing students how real science is being done. So
there's kind of a
yeah, these
roadmap
are
of
some of
research
the other
partners.
projects. I do have a few of these, to be honest, because I'm a citizen scientist. I have a few of these on my phone. Globe at Night is one that is really neat, where you're just recording light pollution. We talked about globe clouds as well. The iNaturalist is pretty amazing. Because we're home, I just downloaded that one. iNaturalist actually has artificial intelligence built into it. So basically I downloaded the iNaturalist app and I went outside and took a picture of my palm tree, and all of a sudden, and I took a picture of the palm tree. It went to the next slide and said sable. Like it identified the plant type all by itself. It's actually got a base in there, like a database. And it's pulling from that database. So if you go outside and you find something and you're like in your backyard and you're like, I found this new insect, I have no idea what this thing is. You open up this app, you take the picture of it, and you move to the next screen, and it gives you the possibility of what that insect is or what that plant is. And then you're collecting all that data. So it's very interesting. That one since we've been home remotely, that's the one that I tried, and I was like, wow, this is pretty impactful, because you have those kids that are out there and you're taking them outside. What is this? What tree is this? What plant is this? What bug is this?
You've got an app for it, huh?
Yeah. The fact that photograph can actually use artificial intelligence, which is, it has a database of a memory that it can actually pull up and, suggest. That was pretty impressive, I found. Yeah.
Yes. Denise and David, there is a question from Linda here, and she is wondering if these projects can just be an observational without participating.
They can.
Right, they can. I mean, you don't have to send your data in. You don't have to hit that button at the end with the data. So definitely just taking part. Yeah, for sure. And if you're going to have a science festival or a STEM night, they're great just to inform the public about. Yeah, they're just great to showcase to families, because families don't even realize, that they can do these kinds of projects. So, even if you're not doing them in school, though, they're great to showcase to get families involved in science.
Good way to build interest for, research-based activities, from a younger grade level and a younger age.
Right.
Let's see.
Okay, and since it is
Wait,
Citizen
hold that
Science Month, this is an article that I did write about citizen science for last month. And David and I are writing for, it's called STEMinformer.org. You can actually subscribe to this newsletter. My article just came out recently. I don't know if you have the link there, David, or you could provide a link at the end for people to
Yes.
subscribe if they would like to subscribe to our newsletter. So the one that I wrote about obviously was citizen science, and so I'm here presenting this evening. Okay.
Contact information.
Yeah, there's our information. If you'd like to get in touch with us, we're both on Twitter. I'm Denise C. Wright, and there's my email, and you see David.
David J. Lockett, yes.
So I could show some, I could also, if you want me to, I could show some of the people these apps. Yes. Would anyone like to see them? I could actually show a few on my phone. So
Sure, go ahead.
yeah. All right.
While Denise is getting that ready, does anybody in the audience have any questions?
We can definitely encourage anyone can try these projects. There's one there.
Okay,
What about robotics? Do you guys?
Somebody asked about robotics.
That's a good question. There's so many different projects that these students can work on. We focus, Summit Central Florida, we focus a lot on life science in our environment, but I have seen a lot of robotics-based programs, where students are focusing on, whether it's the coding aspect or the machine learning aspect as well.
Can you all see my desktop?
Yes.
Okay, can you see my cell phone? Yes or no?
Yes.
Yes.
Okay. All right. For those of you that if you're not familiar with this, this is called a reflector teacher app. I can actually basically broadcast my cell phone to our screen and then screen share with all of you. So if you're teaching remotely, this is great as well, because then you're able to demonstrate the app to the students right in this environment and say, hey, I want you to go out and try this citizen science app, and this is how it works. So the one that that David and I mentioned, and again, I do have to sort of be outside for these, and I'm currently not, so you're not, open up the camera, you're not, I won't be able to take any observations, but there's the clouds, MosquitoMapper, land cover, and the trees. You could see it's found all in one side in one app itself. If I click on the clouds, you could see new cloud observation, review send observations, check satellite flyovers, my observations, and map today's clouds measurement. So it's pretty intuitive. So if you click the new cloud observation, it's actually going to track, Google track where you're at. It's going to use your GPS feature and do that as well. And then it's going to say, you're going to click new observation there. And it's, again, you're just going to, and then you're going to set you could set notifications and click next, but we're not going to do that. So basically you're going to classify the type of cloud. Again, I won't be able to go all the way through this, but let's just say clear sky. And you're going to actually classify the color of the sky. We'll say just deep blue for now. And you're going to also classify the visibility. So we'll say unusually clear. I'm just picking random ones here. Click next. You're going to look at the different ground cover. We're in May, so no ice. We'll say no standing water. We'll say no muddiness. We'll say yes for ground. Leaves on the trees, yes. Raining, snowing, no. Then you click the next button, and then you're going to go out and take some pictures, or we'll skip the pictures for now, and then you can send your cloud data. Okay. And again, I'm going through the app very quickly, but I just wanted to show you, you would go step by step with students and really take them through using the actual app in this remote environment. And they can definitely do that. The mosquito habitat mapper is there as well. And it tells you a little bit about the app. It gives you a step-by-step process about how to use the app or how to use the actual data collection device as well. Go ahead.
Jenny is asking, how does the data get sent to you as a teacher?
Well, you send it out at the end, but if you want to log into the app, like log into this Globe Observer app, you have access to that data. Does that make sense? So you would have access to the overall data. Does that make sense? Hopefully.
Jenny, does that make sense? Tell me if it does not.
So
I did have a request also for, before we wrap up, for you to put the link to your emails back up.
Sure.
Sure. So that's that app. The other one that we talked about this evening, and I'll talk about really quickly, is called Zooniverse. And that's the one that David and I mentioned that's all web-based, but you can do it on an iPad or an iPhone. And again, these are all the breakdowns of the topics: medicine, nature, physics, social sciences, space. Since I am a solar system ambassador, I got to give my friend a plug. He is another solar system ambassador locally, an astronomy professor here at our local college. He was actually on the team for spiral graph. And basically they're looking at the curvature of the spiral arms of the galaxies. He was one of the contributors on this project. It's in beta right now, but they're hoping that it will advance to the actual full site. And him and the head professor at the University of North Carolina in Raleigh were the ones doing this research, and Zooniverse has taken them on, and they're actually in beta review. So people are checking it out and helping them collect data. So again, you could see pretty simple. If I click on space, it'll give me the space projects, Galaxy Zoo Mobile. And again, it can be down online. This one is actually out of data because there's so many people collecting data for them. Mapping historical skies. There's stuff on Mars here, Planet 4 ridges on Mars. There's terrains. This one is Planet Hunters out of data. That was the test satellite collecting for exoplanets. Supernova. So anyway, this is a little bit about the apps and how they work. And hopefully that was helpful for you. And I just wanted to share that as well. So
that was amazing. We did have just a quick follow-up about the data questions. So the clarification was, so the data that gets sent to you or that you have access to is just overall data. It's not specifically to your class.
Well, I mean, what you can do is once you collect the data, like I suggest, to take a screenshot of it and have the students save it to the camera roll
Before they send it in.
Yeah. And
That's what we've done in the classroom.
Yeah, that's what we do it in the classroom, is have them take a screenshot of that data and then put it all up on a big Padlet, which is almost like a electronic bulletin board, more or less. And that data, you come back inside from being outside and collecting that data, and you can see all of that data populating across the screen. And then you can take that data and, write a lab report or graph it, or just have a really good discussion. And it's really great to keep one, but like David suggested, keeping one bulletin board, and then going out 3 months later, collecting that same data again, 6 months later. How is that data changing over time? That's pretty impactful for students to see that. So.
All right, well, we have a huge demand for the link to your presentation slides. And then also, if you could show your email addresses again, that would be great.
Yeah,
and
I'll type it in here in the chat.
Out of time.
Sure.
Yeah, David, do you want to type it in the chat?
Sure.
And I will capture it if you put it in the chat too.
Okay. I could give, that is my private one for like personal one, and this is my full one.
Be careful which one you share.
It's all good. Yes. Okay. Okay. So thank you so much. And
Thank you.
If you have questions, please let us know.
Thank you.
And are you guys going to go to the lodge link and hang out there for a little bit in case anyone wants to chat with you further?
Sure. Where is
Sure.
the lodge link?
Okay, I put that in the chat too. Just a second.
Thank you.
Yeah, so I could just click on that and go there.
Yeah. It's up a ways though. Just a second here. It's a Google Meet.
Those are the ones I do all the time with my kiddos.
There you go.
Thank you.
Thank you. All right, I'm gonna click on this and then hop out of that, I think.
Thank you.
Bye.
Was there a link to the slides somewhere, or how was that going to be shared?
David, did you do that? Let me
Talks
grab.
about
Okay,
a
the
slide
key popped
link on the
out. Let
yeah,
me.
so
Let me.
there's-
Okay,
okay.
let me grab it right now. I have it actually. I'm right here. So let me
Okay.
grab it. Anyone with the link can view. Yep, I got that.
Okay.
Okay, great. Good thing I didn't. I thought I exited out for a second there, but I didn't.
Okay.
There, there's that link, and then
Mhm.
maybe we could also post it on the homepage as well.
Yep, we will, I'll grab it here. I'll put it in the notes so everybody has it.
Okay, that'd be
Yeah.
great.
Thank you.
Where do you find the notes?
I know it was on that homepage.
The
I
note-
saw.
Yeah, the notes are, when you go to the, I've got the link here too, but when you go to the web page on the schedule,
Yeah.
click on their session, it should have the link there to the.
Okay. Beautiful. Thank you
Okay.
so much.
Yep.
Sure. I'm gonna go into the meet. Thank you.